Hi, welcome back to Buy Forever. This is just a quick video, well, hopefully a quick video. If it gets more than sort of 10-15 minutes, then I'll just give up. But it's about the Sinclair ZX81 and using the ZXAS assembler. So did a video previously showing us a little bit way of writing assembly language programs directly on the ZX81 rather than using a PC and assembling it, and then you can run it as well. So you do all this from the basic editor, and the main reason I wanted to do this for some strange reason, I was trying to write just a Space Invaders type game and do it all on either pen and paper and using just the ZX81 rather than a PC. So, and not that was like necessarily cheating, but doing on a PC with modern text editor, well, we just didn't have that in 1981 and the early 80s. So I thought I'd go for the full experience. Anyway, that sort of project's ongoing in the background. I've done a little bit more on it, but I'll do a video later when I get something worth showing. So what I did was just I thought I'll look at another example or an exercise from a book called Assembly Language Assembled for the Sinclair ZX81. And in there's an exercise 5.1, I think it is, that says write a program which outputs an asterisk to the screen, and then checks if the break key's pressed. If the break key's pressed, then return to basic. So in there, it's describing also in a nearby section that a call to ROM routine F43 actually checks the break key and exits to basic if it's been pressed. So this bit of code should effectively print an asterisk screen. So LD, so load to register A, hex 17, which is character, well, I think that's 23, yeah, which is the asterisk in Sinclair character set. Loop, so we've got loop 1, RST10 is another call to a routine. It's just a different way of calling a routine. And that should just print the next character in the accumulator, which is A. So it prints the asterisk. And then call F43 should check the break key. If you press, then returns basic. And then JPL1 just jumps back to loop 1. So it's a really small program. So this is basically using like a ROM routine, which the book says is F43 for this particular thing, to check the break key. And when you run this, it actually crashes. And, just blank screen, nothing. No asterisks are printed at all. So I thought it'd be a good opportunity to try the ZXDB, which is the debugger that comes as a sort of partner program to the ZXAS. And so first thing I wanted to do, so I've installed assembler, I've run that code, and now I just want to assemble this, and I'm doing that to memory location 25,000. Now this output's a bit strange in that it repeats the same code twice for some reason. I don't know why that is. If anyone knows anything other than it just being like an idiosyncrasy of the assembler, maybe it is. I don't know. Anyway, I assembled that code to 61A8, and it kind of looks right. The opcodes and everything look right. So if we ran that now, if we did, I'm not going to do it, but if I did whoa, sorry, I forgot you have to press another key after that. If you did rand, rand shift function user 25,000, which is where we assembled it to, then that will just execute the program. But we're not going to do that. If we can delete it, that is. So what we're going to do now is we're going to try and run the debugger. So I've happened to have that again. I've got ZX81 on here, so it makes it quite a bit easier. So I've got a program called ZXDB, just in the root of the SD card. I'd suggest if anyone out there could get a hold of the ZX81, you know, you can actually make it yourself as well. I think it's all on GitHub. So this is loaded the debugger. The code, we didn't do a reset, so we've still got our program at 25,000. This code actually, ZXDB, when you run it, it, in inverted commas, installs to the same place as the assembler was. So if you run that, so you can see that by looking at like list, the next part of the program. So this effectively does the install 10 print user 16640, runs the code that copies it to 28565, which is where the assembler used to live. So we can just run that and now we're into the debugger. So the commands in this, it's fairly basic. If you type V, it should print values in hex. In fact, that's not. What's that done? I think that's errored out, is it? T, that's like an error code. Huh. So what have we actually got now? So we ran it. So, I think. Oh yeah, so probably want to, before we ran it, we should have actually just deleted the code that does the install, and then we just want to just run this as it is. So yeah, you kind of, once when you load it first time, you get all that bit at the start in the rem statement is like that's the program encoded as basic tokens, and then this is the rest of the thing that you'd actually use to run it. So you have to delete that other bit of code. So now it's just, it should be accepting commands. Nope. Okay, so that's not quite worked. So input. Oh, so it's expecting a memory location to start from. So okay, so we've got to give it that first. This is a bit like the assembler, so I assume now we've got to just put 25,000 because that's where we want to start debugging. Error 1. What is error 1 then? Well, this just doesn't quite look like it'll ever work. So the bug that I was using as reference for this is the first time I actually tried running this. And it did seem to run better the last. Actually, let's just yeah. So cat is actually a ZX81 command, but didn't want to do that. I wanted to load ZXDB.p. Right, so it seems like, yeah, you don't want to delete the first bit of the program. You actually just want to run it. And the star, I think, is the correct prompt. So now it's expecting, commands. So I think it's expecting like a memory address. And no, that's not working. Why is that? Oh, maybe it's actually not expecting a memory address, it's expecting the command. One of the commands you can do is like just display memory. So if you type A, you should be able to put in a memory address, and we should be able to view contents of it. So that's printing it out. It's printing 32 memory locations. But not at, okay, 25,000 is that 5,000 hex. Just check that. I don't know if that is actually. Just get the calculator on the PC. It's just a shame you have to use a PC. But 5,000. Yeah, okay, that's 2480. So maybe actually you have to put the address. The address might have to be in hex. Oh, that's good. So 25,000 is 61AB. So let's try again. You see, if you just press, well, if you just keep pressing a new line, it just keeps going down memory. So what do we want to do? Really want to just do A again. Maybe break. Does break work? No. Appear to have lost control of the debugger. Try Q. Okay, Q should leave debugger and send to basic. No. Q. All right, Q jumps back to the start, which is the command prompt. So let's put in 61. No, it's not like, you know. Oh, yeah, sorry, you have to put A, and then so that's to view address 61A8, because now we're assuming that the address has to be in hex, and it deletes repeated the right command, the right address. So assume that is our program, but that's not really even meaningful to what we saw in the assembler output. So really what we want to do is display in hex. So if we press Q twice, if we press V according to instructions, that should view memory in hex. So again, 61A8. So yeah, that's okay. So that looks a bit more intelligent rather than looking at what these characters mean in terms of, you know, hex values. So you can actually execute the program now. I have no idea whether this is going to work. I don't think this is going to work. So if we just quit back, we go Q to get back to there. If you type G and then the start address of the program, I think it's just going to crash again. You'd hope that it'd run and then oh, okay. So that's totally crashed. That's not even outputting any video now. At least before, when this crashed, this bit of code crashed, it actually just gave you a blank screen. I mean, no better really, but a blank white screen. So quickly look at instructions. You can set breakpoints. So I guess what I need to do was set a breakpoint, execute the program, and then hopefully when I hit the breakpoint, you could step through and at least like kind of get to the instruction that was crashing. There's a lot of other things you can do with ZXDB, and again, I might do another video again in the future, but I think for now I've got to sort of 13 minutes of this video. I'll go away and probably in about 10 years I've figured out how to get this small bit of code to run. Unless, of course, someone in the comments who knows a lot more than me, which is probably most people, will have some idea why, again, this program, which I'll just load, I'll not load the assembly, I'll just load the bit of code that we're trying to get to work, which is just this. So if anyone out there can tell me what's wrong with that bit of ZX81 assembly code, then be my guest. Okay, hope you enjoyed the video. Again, it's another one there where we didn't really solve anything, but maybe it was a journey that was slightly interesting. Anyway, thanks for watching and bye for now.